Find magnetic field at the point O. Take radius in all parts A, B, C parts R, and linear parts are very long. Now, first part I'm taking first, B. So I've named the parts 1, 2, and 3. This is a semi-infinite wire, and a circular wire. Now for semi-infinite, I will be using Ki by distance. See, I have already done this, Ki by distance, and I will be using cross product to get the angle. Get the direction. Don't use any Fleming left hand right and all these stupid laws. You can simply do by cross product and you will never be wrong. So this is going inside. First check how they have given x, y, z axis, x, y, z. So if it is going inside, it's minus I. Can you see that? And if it is going right, it is plus j. So I've done that. Okay. Next comes circle. So it is a Ki by r into angle subtended, that is pi. I've written that. And then minus I, because it is in the plane of the yz plane. So if it is clockwise, it is going to have magnetic field inside, and inside is opposite to positive x-axis, so it's minus I. So I've written that minus I. Now let's talk about this wire. This wire is coming towards us, so I can obviously let Ki by r because semi-infinite. Ki by r is a distance from the observation, point of interest, and let's see the direction. This is plus x, so I, and it's going to the left, so minus j. Okay, so I'm taking Ki by r as the common, then minus I cross j will be minus k, then I have minus I, and then I have minus k again. So I've taken minus outside, Ki by r, k and k gets added, gets 2k, and pi by m, and magnitude we can solve like this. Now let's go to the second part. Second part is this 1, 2, 3. Again I have named it. So B, B1 plus B2 plus B3. So if I talk about B, this is again going inside, minus I cross j, Ki by r into distance only once because it's semi-infinite. Now again this semicircle, everything same. The only thing changes is this one. So the wire, obviously semi-infinite, so directly Ki by r is the answer. And for semi-infinite, Ki by distance is the answer, and distance is taken from the wire to the point of interest perpendicularly. This is the point of interest. So Ki by r. This time direction changes. In the previous question, the wire was like this. This time wire is like this. So this is minus k. Can you see that? The current is minus k, and the point of interest is minus j. That is the change we are getting. Then Ki by r can be taken common. Minus I cross j is minus k. Then minus pi I, and here k plus minus gets cancelled. K cross j is how much? It's minus I. So I've got minus I. Then you can take Ki by r common, minus I also common. Then k cap and pi and I will be, pi plus 1 can be taken, and I can be taken as a common. And if you want to find out the magnitude, so you can simply write this as it is, and ij things go into the square. So 1 square plus pi plus 1 ka square. That's the answer to the question. Now the third part is like this. This time this circular wire makes a 270 degree turn, entire 270, and then it is going toward the positive x-axis. So I'll name it 1, 2, 3. For one semi-infinite, Ki by r minus I cross j as it is. It is going inside, x is going outside. So current is minus I, and it is going to the right towards the positive point of interest, which is toward the y-axis. I've taken as j here. Now Ki by r 3 pi by 2, because the angle subtended is 3 pi by 2, simple. And then minus I, because it's clockwise, it's in the plane of paper, so minus I is the only option. Next comes wire number, this wire number 3. This is semi-infinite wire. Directly we can write Ki by r, and its direction, it is going towards the plus axis, which is I cap, and then point of interest is upwards, which is plus k cap. So I've written all these. Now let's take Ki by r common without much fuss, and minus k is this. This is minus 3 pi by 2 I, and this is obviously I cross k is minus j. We've written this. Now I've taken 2r as outside LCM, and minus also I've taken out. So I've got 3 pi and plus 2j and plus 2k, and that is the answer to the question.